Okay, we're going to talk a little bit about dimensional analysis. Dimensional analysis just is a method of calculation given our knowledge of units. The given units can be multiplied or divided to give the desired units. That is, if the unit's in the numerator, it'll have to be in the denominator of the conversion factor. If it happens to be in the denominator of the unit, it'll have to be in the numerator of the conversion factor. And we can manipulate that by flipping the conversion factor over. For example, for every 1 inch, there's 2.54 centimeters. I can say there's 1 inch per 2.54 centimeters or 2.54 centimeters per 1 inch. Which one do I use? Depends on which way the unit conversion gets canceled. If I'm going from centimeters to inches, I would use 1 inch divided by 2.54 centimeters. If I'm going from inches to centimeters, I would use the other factor. I just need to make sure my units cancel or I don't have the right numbers. So to solve a conversion problem using dimensional analysis, we need to read the problem carefully. We need to tabulate the data in the problem with the proper units, make sure I know what I've got, what I'm going to, what are the units I'm working with, what needs to cancel. We need to determine which principles are involved and which unit relationships are needed to solve the problem. There may be more than one way given the units you have to work with. But you need to plan out what that way is and make sure all the units are going to cancel. So set it up, neat, organized, logical problem, show your work, show the dimensional analysis, make sure unwanted units cancel. If they don't cancel, you set it up wrong. So go back and check. Proceed with your calculation, make sure it has the correct number of significant figures. Refer back to that presentation if you are unsure how to do that. Check to make sure your answer was reasonable. Many people will submit an answer that just quite simply doesn't make sense. So does that answer make sense? If I'm converting inches to centimeters and the number of centimeters I calculate is not bigger than the number of inches I started with, something's wrong. You should go back and check, for example. So that brings us to our first exercise. We want to convert 8.0 times 10 to the negative fifth centimeters to micrometers. That's a metric to metric conversion, so we'll need to use our metric multipliers. We can set that up with dimensional analysis, or we can just move the decimal place, and I will show you both ways. All right, let's look at this first problem. This one's a metric to metric, and as advertised, I will show you how to convert both ways. We'll start with the dimensional analysis first. So we start with 8.0 times 10 to the negative fifth centimeters. Now we're going to need a conversion factor. In this case, I want centimeters to be on the bottom, so it'll cancel, and meters to be on the top. We're going to write down the numbers just as they appear in the equality next to the unit they appear next to in the equality. And so 10 to the negative 2 goes on top, 1 goes on the bottom. Centimeters cancel. We need another one because we're not quite there, right? We're in meters. We need micrometers. But now this time, meters goes on the bottom because we want the meters to cancel, and micrometers goes on top. So this can be 10 to the negative 6 meters on the bottom, 1 micrometer on the top, and the meters are going to cancel. Running that through your calculator, you will get 0.80 micrometers, or if you leave it in scientific notation, you get 8.0 times 10 to the negative first micrometers. And that would be your answer. But if you don't work the dimensional analysis, you could just move the decimal place. And so that's what we'll do next. We have to look at these units and see how many places. Between -2 and -6, we find there are 4 decimal places. But should the number get bigger by 4 places or smaller by 4 places? Looking at the units, centi is bigger than micro, so I'm going from a big unit to a small unit. Therefore, if the unit gets smaller, the number had better be getting bigger, which in this case it does, but how does that work out numerically? If we're still in scientific notation, we just look at the exponent and we add 4 to it. So that would take us to 8.0 times 10 to the negative 1 micrometers. If you're not, you're going to have to look at this number in decimal form. And so we got 0.0000080 centimeters. Now, notice converting that number. When you've got the exponent to minus 5, you're going to have 4 zeros, and then the next decimal place will go behind the first non-zero number. But now we know we need to move it 4 places, and we need to make that bigger. So that means we're going to move that decimal place to the right. So 1, 2, 3, 4. So the decimal place can go right there, which still gives us 0.80 micrometers, which would be our answer again. The next problem, we convert 55 miles per hour to kilometers per second. This one's a little trickier than perhaps the other ones might be because there's a unit denominator, and we'll have to figure out how to deal with that. Okay, so next we'll look at this conversion. 55 miles per hour, kilometers per second is where we want to be. So we've got a convenient miles to kilometers conversion in our list of unit conversions. And we got some time conversions. 1 hour is 60 minutes, 1 minute is 60 seconds. Taken together, 60 times 60 is 3,600. So we could say 1 hour is 3,600 seconds and use that and simplify our conversion. So if we say 55 miles per hour, we're going to have 1 mile is 1.61 kilometers. Miles are going to cancel. And then 1 hour in the numerator, because we want to cancel with the denominator, is 3,600 seconds. And so then the hours cancel, and we're left with kilometers per second. So all that's really left to do is run it through our calculator. So 55 miles per hour times 1.61 kilometers per mile divided by 3,600 seconds per hour. We're going to get 0.0245, etc. And we're going to round that because of 2 significant figures. And so we're going to call that 0.025 kilometers per second. And that's what we're going to report as our answer. In this next problem, we're going to convert 100 inches squared to meters squared. That decimal after the 100 implies that I'm going to treat that as a number with 3 significant figures for the purposes of this problem. In this case, the unit is squared, and that means we're going to have to do the unit twice. If the unit's cubed, we're going to have to do it 3 times. So that's the wrinkle to this problem that we want to take care of. Okay, let's look at this next problem. And in this case, we're trying to convert inches squared to meters squared. And we're going to use 1 inch is 2.54 centimeters, which we've talked about that one before. And we're going to use the centimeters to meters conversion that we used before. There's a little twist because it's square. So 100 inches squared, And then we're going to put 1 inch on the bottom, 2.54 centimeters on the top. Is that going to cancel? No, because it's inches squared, and this inch will only cancel one of those. So I have to square that entire thing. Now once I square it, that's inches squared, and it'll cancel. And then the same thing will go here. I need the centimeters to cancel, so centimeters goes on the bottom, meters on the top. 10 to the negative 2 meters per 1 centimeter. And again, that has to be squared. Running that through our calculator, we get 0.0645 meters squared. That answer makes sense because meters is a much bigger unit than inches, so that number had better be getting smaller. So that will be our answer, and we rounded to 3 sig figs here because we're treating that as a number with 3 sig figs, as I mentioned before. All right, this problem is one of our study questions, but it's a drug conversion. This one's a little different than other problems that were in this presentation in that most of what you need is right here in the problem. The dosage recommendation for a medication is 5.03 milligrams of that medication per kilogram of body weight. How many cc's should be given to a patient who weighs 144 pounds if the solution contains 18.7 milligrams of medication per cc? In this case, the only outside conversion I need is my pounds to kilograms conversion. The other conversions are actually stated in the problem, and so we'll be able to work with that. Sometimes you have to look things up, and that's something you'll have to get used to. Not every conversion is going to be one you have memorized. Okay, so looking at this problem, I've written all the information, and I've added the conversion between pounds and kilograms from your conversion sheet. What we'll start with is the weight of our patient, 144 pounds, but we're going to need that in kilograms because that's what they usually work with in the hospital. So 2.205 pounds to 1 kilogram of body weight. Now we know our dosage recommendation right here is 5.03 milligrams of our medication per kilogram of body weight. So now we can see the pounds cancel, the kilograms cancel, and we're left with how many milligrams should be dispensed. Since this is a liquid medication, we'll go to cc's, but you could just as easily go to tablets or something else. So now we're going to use our last thing, 18.7 milligrams of medication, 1 cc on the top. The milligrams are going to cancel, leaving us with cc's. Rounding to 3 sig figs, once you run all that through your calculator, will be 17.6, we'll say, cc's of medication. And that would be your answer.